Hi, everyone. In this video, I'm going to talk about order statistics. Order statistics is to return the kth smallest element or the kth largest element in the list of n distinct numbers. Please note that these numbers are distinct. So this k could be 1, could be 2, could be 3, for instance, and could also be the middle, the median, which is n over 2 with the floor. In other words, we may want to find the first smallest or the second smallest element in the list, or want to find the largest or the second largest, and so on. So now let's look at this problem. In particular, if we are allowed to sort, okay, so then it's easy to do, right? So we can sort the list, and then we can easily return the kth smallest. So as we know that using comparison sorting methods such as merge sort, quick sort, and heap sort, we can obtain big O of n log n time to solve order statistics, or we can use linear time algorithm using counting sort or bucket sort when the numbers satisfy certain conditions. And our question is, can we do order statistics in linear time for any inputs without using sorting? So this is without sorting, because sorting is overkill. Now let's investigate the idea a little bit. Let's say I have a list A. So this is my list. And then let's say I want to find the first smallest, which means the smallest of A. And we know that we can use the idea of insertion sort. And to find the smallest can actually be done in linear time. And then if we want to find the second smallest, we need to first do the smallest first, and then we do the second smallest, so which means that we have to repeat this for 2 times. And if we want to do k smallest, okay, then we have to repeat the procedure for k times, and that will end up with a running time of big O of k times n, which is not linear. So that's not going to work. And so now let's investigate another idea. Let's use divide and conquered, right? So that is the idea for a lot of things, right? So for this case, we think about, we want to divide this array, this list into 2 parts such that we can use a pivot element as we did in quick sort. So for instance, let's say this is my pivot, and then I'm going to divide them into 2 sublists with pivot in the middle. Right, so this is a pivot. And such that any numbers on the left-hand side is less than the pivot, and any number on the right-hand side is greater than the pivot. Since we want to find the k's smallest number, and then if this is equal to k minus 1. So in other words, if the left list has k minus 1 has exactly k minus 1 items, then this pivot is actually the k's smallest. So if the left list, the number of items in the left list is not exactly k minus 1, so it could be greater than, k minus 1. In that case, that this k's smallest number will be in the left list, or it is less than k minus 1, and in that case, the k's smallest number will be in the right list. In either case, we only need to look at one sublist. In the first case, that when this left sublist has more than k minus 1 items, then we don't need to look at the right sublist. Similarly, for the other case, that we only need to look at the right sublist. We just need to indicate for here, the k's smallest, when we go to the right-hand side, is no longer the k's smallest, because we have already removed all of these items, so which then will be k minus, so we have to remove these things, right? So so minus something altogether here. And then we can use the right sublist to proceed recursively. All right. Okay, so this is the idea. Now let's look at a concrete example. So let A be this list, 205413. So we use the quick sort idea. Let me place these numbers here. 2, 0, 5, 4, 1, 3, and this is the pivot. So according to the partition procedure we looked at earlier, so this we begin with I starts from 2, and also J starts from 2, and J now, the number at location J is less than 3. So then J and I swap, but since this is the same, so it doesn't swap. And then swap is the same, right? So then we move I up. And then this time J is also move up. And now look at this J. And J is less than 3, so then these supposed to be swapped, but because it's the same, so, and this I will move up, and J will move up, and now looking at the number at location j. This is greater than 3. So there is no swapping. And then move j up. And 4 at location, get the current location j is greater than the pivot. So there is no swapping. And then we move up here. So this time now 1 is less than 3. So we're going to swap these two to get 2, 0, 1, 4, 5. And then now I is moved up. And that's 3. So we are done. And then because we are already in here, so there isn't any more items left. And this time we're going to move this, swap uh, the number at location I with the pivot, so that we get a partition, which is 2, 0, 1. This is the left list. And then 3, which is the pivot. And then on the right is 5, 1. So that's what we have here. Now, we are going to look at, so this is 2, 0, 1. And here we're going to look at the third. And the item here is a 3, okay, which is not equal to 3 minus 1, which is not equal to 2. So that means that this is the number of the number of items in this list is greater than uh, k minus 1. K minus 1, k is a 3, so it's greater than 2. So which means that we can discard these, and then we're going to find the third smallest from this. And we repeat the same thing, and but as you can see, that 2, the answer will be 2, but we can see why it is the case, and we can repeat this. So this is going to be my pivot, and this will be my I. This will be j, so no change, and j move up here. So there is a and here j is uh, j is less than, I'm sorry, the item at j, location j is less than the pivot, so we're going to swap with the item at location I, so which we get is 0 to 1, and then move I up. So this time I stop, and then we're going to swap these two, so we get the partition which is 0, and this is 1, and this is 2. Okay, and looking at this, we know this is less than 2. The number of items in this list is less than 2. So that means that our third smallest will have to be on the right, in the right list. But now it only has one element, so which is the answer. So this is the third smallest. Okay. So now we are going to look at how we're going to write this in Python. I will call this case smallest, and then we're going to, because we're going to recursively call a sublist either on the left of the pivot or on the right of the pivot. So their lower bound and the upper bound will be parameters. So we call it P and R. This is the left boundary, and R here is the right boundary. Okay, so we first check to see whether K is greater than R minus P plus 1. If it is, then K's smallest number doesn't exist in A because the size of A, which is R minus P plus 1, is less than K. Otherwise, then we're going to find it. Okay. So first we do partition. And if the, so we do a partition, which we get it here. So this is uh, the pivot at index Q. Okay, so this is Q. And then the right list is here. And we're going to see uh, how many items in this part. So we know the left boundary here is a P and here is a Q. So you have Q minus P plus 1 many items here. So if this is equal to K, then this pivot will be the K's smallest. So hence we return A of Q. Otherwise, if it is greater than or equal to K, actually because these numbers are distinct, so we just need to say if Q minus P plus 1 is greater than K, then we're gonna drop this. Okay, and we're gonna drop the pivot, and then we're gonna stop here because we know pivot cannot be the case smallest. Okay, so hence we're gonna change the left boundary will be P, the right boundary will be Q minus 1. Otherwise, we're gonna drop this and then move to this, which will be Q plus 1 to R. So from here, but then since we already move here, so this is the boundary, and then instead of the K's smallest, it will be K minus the numbers here, which is, we know that it will be Q minus P plus 1. So which will be then K minus Q plus P minus 1. So that's what we have. Okay. So then partition, we know how we do partition. So we use the rightmost item as our pivot. And we already looked at it a few classes ago, and I also just went through an example, so which should be pretty clear. Okay, so then we are going to write a driver's code, and we just, okay, this is our list. And this 9, the meaning of this 9 is that the code within it, okay, so this 9 says that this 9 indicates that this part is only, so this function or the whole block is only executed when the script is run directly and not when it is imported as a module. Okay. Okay, so now let's see it. We're gonna run this and run this. All right. So for this one, let's just visualize the third, well, it should be the third smallest element. And you can do a better print statement so that when I is equal to 3, you should get third rather than this, right? So, but that is a minor issue here. And if we want to visualize this, the third smallest, okay, the smallest is 3, and the next one is a 4. That's the second smallest, so the third is 5, right? Okay. Here's another example. Okay, so in the next video, we're going to look at complexity analysis of of this case model algorithm. Thank you for watching.